Hello and welcome to the Tetration video series. My name's Rob and I'm here with Remi, and in this module we're going to speak to Tetration software agents. Now Remi, software agents and sensors, these terms are somewhat used interchangeably. Could you maybe just elaborate in terms of where that has come from?
Sure. I mean, there's a bit of history, let's be honest. Like, Tetration started a few years back. Tetration only had visibility, and when we started with visibility, well, sensor makes sense because a sensor does not change anything. We actually evolved, and the sensor can now do things, enforcement. So a sensor becomes an agent. So we kind of interchangeably use both.
Yep.
So if you see sensor or you see agent, it's actually, in our minds, the exact same thing.
Okay, so effectively an agent is a form of a sensor and can actually do more than just sensing or have telemetry or inbound input into Tetration, but it can also be a control point.
Absolutely.
Okay, so maybe let's just take a look at the different sensor and agent types that we have in the platform and what different options we have based on the environment that the customer has.
Yeah.
So over on the left-hand side, we've got our core software sensor framework here. And we've got different offerings according to the different operating systems that exist in every environment. Now, some customers might be certainly more heavy on the Linux side or the Windows side, but between the two of those, we've got a very broad set of versions and distributions covered that gives us a pretty wide coverage on the whole in a large majority of the environments, right, Remi?
Yeah, that seems pretty complete from what I see. I mean, I seem to have nearly everything there. I see Linux, Windows, for Tim especially, Z systems, PowerPC. So Z system, by the way, I just looked at it. It's like Z system is like a platform, right? So we're supporting more specific stuff, right, on Z.
That's right. So as we kind of step down through the list here, we kind of move from perhaps more of the mainstream operating systems to different platforms. And we've got a section in the middle here that's specifically covering the IBM platforms. So there is the Z series platform, which has different operating system options available. So here we're specifically talking about Z Linux.
Okay.
Yep. And there are, again, different distributions that run Linux as part of the Z Linux, and we've got coverage across multiple of those to really give us a way to actually get data out of those mainframe environments.
Okay, so specifically, while we say Z system because most people are familiar with Z system, the specific one we support is SUSY on Z today.
Okay.
By the time you watch this video, it might be totally different.
Maybe I stepped ahead there. Okay. All right, good to know. And then we also have AIX. So AIX is another fairly prevalent platform in the IBM space. So we've also fairly recently introduced AIX support for those environments.
That sounds good. By the way, I'm just looking at those, and so it says sensor. We're talking about sensor versus agents. Mm-hmm. Which ones are sensors? Which one are agents? Which one can view stuff? Which one can actually enforce? What's the difference in there?
Well, these are all agents,
okay,
Remi. And so with the agents, and I guess this is probably an appropriate place to introduce the different sort of types of agents that we actually have as well. So we do have deep visibility agents, and we've got enforcement agents. So the enforcement one with the capability to actually take a policy and to enforce it into the operating system.
Okay. I mean, that makes sense. And is there a third type of agent? Because I heard like a very special agent, very, very special.
If you're referring to universal agent, is
For
that the third one? Okay. Yes. So in environments where we actually, and it's typically for more legacy operating systems, maybe back in the 32-bit days where we don't have a native sort of full capability agent supported
okay, so
there.
When you say legacy, you really mean legacy this
I
time?
really mean legacy, not
AIX legacy.
No, I'm definitely not stepping into that territory. So yeah, we're talking about things that are well typically beyond their end of support and so on, but there's still a need for just visibility. So a universal agent gives us the ability to actually get some understanding of the communication patterns in those workloads to be able to use that to derive policy.
Okay, I see.
So the universal agent does not give us an enforcement point. It's really just, and in a lot of cases, it's really to be able to build policy to enable a longer term migration to actually get off of those platforms.
I see. So there is, if I understand right, there's like three main types of agents,
Yep.
and one is the enforcement one. That's the one I believe we recommend to deploy.
Yep.
The visibility one, which basically cannot enforce, full stop.
Correct.
And universal agent, which is a very lightweight agent, but actually doesn't give a lot of data. The data it gives is really targeted to migration only, so no enforcement, nothing there.
That's correct.
Okay.
Yeah. And it also doesn't give us the full flow telemetry that is going to give us the ability to go back and the full forensic record and searchability of those flows. It's about understanding the connection state so we can build policy.
Okay, so would it be fair to say it's like a lightweight net flow with process appended, something like that?
You could call it that, yeah. So and
I don't want to insult NetFlow. Or
no. So really, I think if we look at the core of what we've got on the screen here at the moment, these are our core software sensors and agents. And with these and the coverage they provide, it really covers the majority of customer environments today. There will be exceptions beyond that, and then that's when we sort of step into, well, maybe universal agent is an option there. But also we've got other sensor types as well to help us to kind of fill out around perhaps where we don't have agent support.
I see. So what we're talking about is more the exception. Like I remember a customer having a Windows XP server. So already something is a bit interesting. Yeah. Windows XP server that runs their cameras, or Windows XP server that runs their door control systems, access control system. So those ones would be a good place to put a lightweight sensor, for example. But any place where they run things like modern Windows OS 2008 or 2, 2012, 2016, all that stuff, then we'd go for an enforcement sensor.
That's correct. And the enforcement sensor has the full visibility and the capability to enforce policy within it as well.
Okay.
Now, and that is something that is also controlled through the agent configuration, which we will speak to in a subsequent module as well.
Okay. Yeah, already that part seems pretty clear to me.
Okay, so maybe just to kind of complete the list over on the left-hand side here, we step down through Linux, Windows, the IBM environments, desktop VMs. Now that's perhaps an unusual one from a data center and cloud perspective, but it's probably important to note here that the caveat to that is we're focusing on virtual desktop environments for this. So for users that are out in, say, the campus environment, we've got a different agent type that's there to support those. And that's over on the right here with the AnyConnect. So these, in the data center, the cloud, the environments we support with the direct Tetration agent, and we've got one that will actually support Windows desktop VMs in that case.
Okay, so if I get my laptop, if I get a Windows laptop and I put an agent on it, that's actually not supported, right?
That's correct.
Okay,
Yep.
But if I get it to, I don't know, like VDI desktops, or if I get it on a point of sale which has a static IP and never changes,
yes,
that's kind of okay.
Yeah, so it's more if it's a more static environment. So we're not looking for deploying the Tetration agent on a laptop that's going to end up in the coffee shop down the road and it's going to be on Wi-Fi and over VPN and all that sort of stuff. That is the realms more for AnyConnect.
I see.
Yep.
Well, that makes sense. Anyway, we said Tetration at the center platform, right? So,
correct. Yep.
Okay.
Okay, and this then brings us to the last element on the left here, which is the container hosts. Now, often people think containers and agents. The first question that arises, and I'm sure you've heard this many times, Remi, does the agent go on in the container or on the container host? Do you want to elaborate a little bit on that?
Yeah, that's a really good question, and you're right. It comes up every single time. Yep. Our approach is a little bit different. So when you have containers have the notion of a namespace. And inside this namespace, you can actually go and enforce policy. The namespace is actually owned by the host operating system. So the way we actually implement policies is that we deploy the agent on the host or the node in Kubernetes, and then we actually push the policy inside the namespace, which means that you have one agent across the host for all the containers running inside it.
Right.
So that's a pretty good deal. I mean, you can have one agent, 1,000 containers on the host, just works.
Yep, fantastic. And it's definitely the right approach. Like we don't really want to be in that position of having agents deployed at, in each and every container. That's just simply not a scalable approach.
I mean, it would become a bit complex. Like you would need to have a systemd and so on set containers, which doable, but then you're talking privilege, so it's kind of a mess.
Yeah.
So I don't think that seems a valid approach. And we didn't want to block the CNI neither.
Yep.
So that's another important concept in the container host, that you want to run Flannel or Canico or Cilium or whatever. Go ahead. We're not going to block you.
Okay. All right. Excellent. So that gives us pretty broad coverage in the types of workloads we're going to see in data centers today. We cater for, I guess, the most prevalent through to the legacy and into the very new. So those newer applications that are being heavily deployed. And again, not only in containers, but across different environments. It's not just data center, it's also into the cloud.
Yeah, that could be, you're right, that could be EKS on AWS, or I can't remember the name on Azure. That's in AKS, Azure Containers, Kubernetes Services.
Yep.
Get there, or the equivalent in Google, GKS, and so on. I mean, there's no limitations on that.
Yeah. Okay. So that then brings us to these other agent/sensor types over here. And in fact, just taking a quick look through, AnyConnect certainly is an agent that gets deployed to the user devices, and that's going to be a source of telemetry, and not just in terms of flow data, but also context around the users that are logged into those devices.
That's fair. I think you raise a good point, because you're right, AnyConnect is absolutely an agent. I think when we say software sensor or software agent, I think we maybe should word better is Tetration owned agent.
Yes.
So you deploy the agent for the use of Tetration and Tetration only. AnyConnect is more interesting because we say, Mr. Campus owner, you own all the AnyConnect fleet. I mean, we're not going to interfere with that work. So AnyConnect has this module called NVM, Network Visibility Module, that allows to send telemetry out to other systems, be it Tetration, other stuff there. So what's happening actually there is that we ask whoever owns AnyConnect to send data out through NVM to Tetration.
Yep.
So no new agent, no new module that we're pushing from a Tetration side, owned by the campus or whoever owns the system, just configuration towards Tetration.
Yep, that sounds the right approach, right? Because they're going to be different teams that are controlling the user devices versus the workloads in the data center. Tetration's core focus in the data center, but the ability to bring that data in, very valuable insight into the users accessing the applications. On top of that, we've really got a combination of things here. There's the combination of flow data and context data here. So, and in a lot of cases, a mixture or a combination of both of those. If we start from the top here, we've got the VPC flow logs. So this is a way to actually ingest flow data from AWS in this case for, again, a set of workloads where we don't necessarily have coverage with agents.
That makes sense. I mean, try to put an agent in a Lambda. Good luck with that. So flow logs are a great point for us. Try to put an agent on things like Aura DB or stuff like that, which are I call them their cloud native services that you may use from maybe an EC2 instance. So the EC2 instance you'll see because you can put an agent, but maybe you have a Lambda talking to the EC2 instance and talking to the Aura DB. So how do you see this connection? And that's what the flow logs give you.
Okay, so the virtual machines that we deploy into cloud, we deploy the agent to. The other services, the other sort of native capabilities of the cloud that we're not going to natively understand. It will just be some sort of communication path within the cloud. This gives us the extra context around what are those services and how are they being accessed.
Absolutely. It's basically just filling up the gap. That's what it is.
Excellent. Now, we've talked about users and AnyConnect, where we've also got Cisco ICE. And both of these relate to endpoints, or the users that are accessing the applications. Could you just quickly contrast why we've introduced ICE support together with AnyConnect and how the two compare?
It's an interesting topic because AnyConnect actually gives you quite a bit. Because AnyConnect can actually give you process data, just part of the NVM module. It gives you flow data, which is things that we're looking for. So it's interesting to deploy. But there's actually a way where you can do zero agent and get full visibility across the environment. And that links into things like, for example, medical devices. You can't put an agent on a heart monitor.
Yep.
I mean, you probably don't want to touch that thing. So that's a good thing. So how do you know what's the identity of this IP on the network? In the sense, imagine this scenario. I come in and I manage to hack through a heart monitor system. And then I'm connected into the network, the hospital network. I'm going to try and scan and to move around in the environment. Now, if I want to know that actually a heart monitor is trying to access a file server, I mean, that's a red flag. So that's the reason why ICE is actually very valuable for assets where you either don't want to or can't put an agent on. And we can see that like on our laptops at Cisco, we have AnyConnect, but we're actually using ICE for wireless, ICE for .1Q, for .1X. So in the end, it's a pretty good way to get everything.
Okay, excellent. So ICE integration is not about getting flow data, it's just purely context. So
absolutely,
this device that's connected in and is perhaps accessing an application in the data center, who is it? So what is the user, what is their identity, but also what device are they on? Is that something that's actually been validated, again, to allow it entry into the network? And is that useful context for being able to make a policy decision, not just on the user and their group, but to make sure that they're on an appropriate secured device, and perhaps with some other characteristics as well that are important to actually define the policy.
Sure, you're thinking posture, stuff like that, for example. Yeah, no, absolutely, you're right. So you can actually pull that.
Fantastic. All right, now we get into some other sources of data. We have Cisco ASAs here. Now, we've got ASAs which are a firewall. Now, the ASAs will be passing traffic through, but there's also two sides. If there's a NAT that's taking place on the firewall, then the flows on either side will be different, right?
Correct.
So how do we, and I guess what I'd like to explore, Remi, is how users accessing applications through a firewall and through a NAT, how do we actually create the policy around that?
So indeed, the fun side of campus, it happens in DC, but very rarely, is obviously NAT. NAT is something we should never have invented. But anyway, that's what it is now. The problem with NAT is that if I see a flow, so let's take your laptop. Your laptop has IP.1, and it's connecting to a server, which is IP.10. But to access IP.10, it needs to go through a different network. And so your IP.1 is going to become IP.3, for example. If I design a policy that says IP.1 is allowed to talk to IP.10, it will never work.
Right.
So what ASA provides, ASA is a great complement to ICE. They go really hand in hand on that. Is that I see Rob.1 trying to access the system is going to hit the ASA. ASA is going to transform .1 to .3. So it's going to report, oh well, .1 is now .3. So when I see the policy coming back in, I know where this user is actually coming from. And the policy I need to set here is probably .3 in that context, if I need to set it there. Or I can rely on more advanced technologies like the load balancer, which we haven't talked through yet, which can actually stitch that very nicely for me.
So the concept of flow stitching, which we see on both the firewalls and the load balancers, is about handling NATed environments.
Absolutely.
Right? And typically, again, user to application through a NAT, how do we make sure that those addresses line up and we're actually applying the policy against the correct entry?
The correct entry, absolutely.
Okay. So let's just maybe touch on load balancers since we're there. So we've got support across different versions or vendors of load balancers. The fundamental part of that is, again, visibility in terms of flows, the flow stitching, really along the same lines as we saw with the ASA. But there's more that we can do with load balancers, right? They're a more capable sort of application device that's playing a role in the, the application itself. So what is this extra enforcement capability and how does that fit around what we do directly in the agents themselves?
It's interesting to raise those. F5 Citrix and Navi, from a load balancer standpoint, are like other sensors, but sort of an agent as well. So they sit a bit in the middle, in between. There's a thing which, so load balancers are great devices, but they're really a pain as well, let's be honest. You access a VIP, and this VIP sends traffic to a real server. The problem is that you need to define the policy when you're saying, I want to expose the web cluster here. I'm actually not exposing the web cluster. I'm actually exposing the VIP. But the traffic the server will see, if you're using, for example, server load balancer in NAT mode, is actually going to be the internal IP of the F5 device. So I actually need to translate this to actually allow that. But now I just create a problem, right? I have traffic coming in, one IP accessing the external IP, but then the internal IP is actually going to be the same for all users on the outside. So that's sort of a problem, because then if I allow a flow from the backend to the backend server, I'm allowing everyone. Now, if we can actually push policy to those devices to tell them, you know what, actually, I want to allow a specific user. And if you want to allow a specific user, you're actually going to take the IP of that user and you're going to put it on the VIP in terms of enforcement. So your enforcement is happening at two levels. In level one, the VIP has a policy that will only allow this user to connect. Second level, the backend can only talk to those sets of backend servers. So you actually get 2 in 1 for an enforcement point when you're using ADC devices, application delivery controllers.
That's right. We shouldn't call them load balancers anymore, right?
Yeah, we might get. I know a few people that might get a bit upset.
Yeah,
I think load balancers are considered legacy as well.
That's right. That's right. So that really leaves us with the last two pieces of the puzzle, being ERSpan and NetFlow, both sources of flow telemetry. Now, they're different, though, obviously, and this is something that we discussed in our sort of overall introduction or overview to data sources. ERSpan being the recommended source of flow telemetry, really for areas, again, where we don't have agent coverage, where we're, again, trying to sort of fill in some of the gaps to give us more visibility. Now, the ERSpan sensor is really implemented more similarly to what a software sensor would potentially provide in terms of the ability to actually take the data in, to extract the right metadata, and then to stream it back to Tetration. So where would you suggest, I guess if we were to contrast these two a little bit further, where would we use ERSpan versus NetFlow?
So I'll be honest, the least you use them, the better.
Yep. Let's
put it like that. What do I mean by there? ERSpan and NetFlow are great ways to kind of fill gaps. That works really well for that. But they're lacking one of the fundamental piece of data we value is process data.
Yep.
I mean, except if you found a way to get the process name from a network flow, I think that's something that we can't reverse engineer. So the goal of the ERSpan is to say, look, you may have a mainframe. This mainframe is running somewhere in your environment. And mainframes usually is like, don't touch that box because it works, which I value a lot because there's lots of critical systems running there. So I could say, look, I have a device next to the mainframe, maybe Nexus 9K or something else. And I'm going to turn on the ERSpan capability of the mainframe, of the switch, which is then going to send me the data which is actually flowing between the ports on the switch. So I don't touch the mainframe at all. I touch a network element, and I can send this telemetry to fill in the gap. Why did we approach it like that? I mean, the chances you're actually going to use an enforcement point on the mainframe is very low. I mean, every time I raise this question with the mainframe admins, they look at me like, really? You want to do that? So we prefer to keep the enforcement point outside of the mainframe so it can do the job it's doing and does it really well, and that's it. So that's ERSpan. Then comes NetFlow. So NetFlow has actually a lower resolution in terms of quality of data than ERSpan. ERSpan, we still see packets and flags, and so we can find direction of a flow, who's the client, who's the server. And how do we find that? Well, who sent the SYN? That tells us the direction. The first initial SYN allows us to find direction. NetFlow gives us aggregated data, so we can't really figure that out. So where does NetFlow actually shine? Edge devices, for example, campus edge, data center edge, things like that. Pretty nice place to put a NetFlow device. I've seen some customers using it on the DVS on VMware. I mean, I can't comment on that. I don't know the scale implications or things like that. But that could be an option. Or devices that actually natively support NetFlow. An interesting case recently, so I learned that HP Tandem, which is used a lot in the banking around the ATMs, actually apparently supports IPFix.
Okay.
IPFix happens to be NetFlow v9, which is a protocol we support. So you can actually send telemetry now from a mainframe kind of device, Tetration.
Yep. So it's kind of there's effectively an ordered set of preferences in terms of the sources of data and telemetry that will kind of give us the ability to fill out the picture.
Yeah.
And we want to start with the agent deployment as far and wide as possible, but be able to extend that out. We want to extend that out to the campus. We want to bring in the user context and sort of flow data, the process information through ICE and AnyConnect. We've got sources of data from the cloud, and then we're also able to do stitching of the flows in and out of the data center, fill in the gaps with ERSpan and potentially NetFlow where it's appropriate.
That's absolutely right.
Okay.
So green is good.
Yes, green is very good. And really, I guess just to sort of have a last comment in terms of the software sensors and the key, I guess, intent we had when we were building and designing these. And that's really some of the principles outlined below here. Absolutely focus on low overheads. That is also, again, question number one that comes up when we talk about agents and we introduce those to the systems guys. What's the first thing they say, Remi?
I mean, no agents on my system. You add one agent, you need to remove three.
Not another agent, right? So look, there is definitely a focus on the overheads of those, keeping that low in terms of CPU, memory, bandwidth as well as just efficiency in terms of how they're built. The full feature set and capability in terms of visibility and enforcement through those. And again, together, we've got a broad set of abilities to bring data into the system efficiently.
I think that's fair. One point I would add on that is, why do agents have bad reputation? Well, do you have an antivirus on your laptop?
Of course.
So if you do, you know why. So the problem with the antivirus and other systems is they tend to hog your CPU, or your file access and all that stuff. And so you come into a situation where it's actually draining your system resources. So people say, I don't want any agents. So those are the reasons why we actually push down. So if you hear like, I don't want an agent, dig into the why you don't need an agent, because most likely those points are actually going to alleviate the problems around that.
So that really summarizes the different agent and sensor types that bring data into Tetration, both flow data, telemetry, but also the ability to enforce the policy through those agents. So that concludes this module on agent overview. For more detail, please go to cisco.com/go/Tetration. Thank you.